This conference will now be recorded.
Okay, so what we'll see, one last thing in exception, is how do you handle variety of failures. Okay, now Ashmita, what do you suspect will happen here?
Yes, sir.
What happens here?
That will give an error.
And what specific error is that?
It is divided by 0, so
Right, that's the message, divide by 0. But do you recall what was the actual exception name?
that is gonna be runtime exception.
Okay, that's a broader category. Datta?
Yes, sir.
Which exact exception happens here? Does anyone recall?
Arithmetic exception.
Arithmetic exception.
It's a arithmetic operation related error. So it's an arithmetic exception. Very good. All right, Rajan, what exception do you get here?
So we have not initialized student here, so it will be I forgot the name of the exception.
Null pointer exception?
Not null pointer exception, yeah.
Yes, null pointer exception. Okay, that's the most important exception ever. Okay, do not forget that. Do not forget how to fix it. Do not forget how to find that issue. Okay, it's the most difficult one, and everyone has to get familiar with the null pointer exception. All right, Sabuj.
Yes, sir.
Will there be any problem in these lines?
There won't be any problem.
Varda?
Yes.
Will there be any problem here?
No.
If the size of an array is 2, how the
Yes.
indexes are stored?
0 and 1.
0 and 1. So when you try to read item number 2, do you find any?
It's 1. No.
So remember that. Okay, so if the size is 2, the indexes from the array can be size minus 1 because all the indexes start from 0. Okay, Sabuj?
Yes, sir.
Varda, did you get that?
Yes. So it's not going to print 1 because 0 is number 1 and 1 is number 2, right?
Yeah, if the size of array has been declared as 2, the variables that are in this group of array will be starting from 0.
Yes.
Okay, so what you say is nums of 0 will be the first item.
Yes. Okay.
Okay, nums of 2 will be the third item.
Third item.
So
Yes.
you have 3 items in this array.
No.
So this will cause an error. This will cause an exception. Do you recall what's the exact name of that exception?
It's no, I don't remember the name. Array out of bound or something.
Array index out of bound.
Array index out of bound. Okay, array index out of bound. Okay. All right, so let's see multiple catch blocks. Okay. If you try catch this in only one block, you can still write the code. Okay, you can still write the code. Okay, we know all these lines are bound to throw some kind of error. But do you see any problem with this? If this fails, what is the error message will you print? We are catching that exception and we are printing something. If an error happens on this line, what will be the output? What will it print on the screen?
Exception happened.
It says exception happened. That's what you do sys out. If error happens on this line, what is your message?
Same, exception happened.
Exception happened. If error happens on this line, what will be your message?
Same one, exception happened.
So do you see the problem? The developer has no idea what went wrong. Okay, just like the customer. I gave you the ATM example, right? When you're using a ATM software, things might go wrong in 10 different ways. Your card has been damaged. So when you swipe in, it doesn't work. Your PIN is invalid. Whatever PIN you enter, it doesn't match. You do not have enough balance, insufficient fund, or the ATM doesn't have enough cash to give you. They ran out of money. So the transaction can fail in 10 different ways. What will happen if your message always says only one thing? Transaction failed, exception happened. Does the customer has any clue on what needs to be done to fix this error? Did you give them any proper action item on what should they do to avoid this? Your card has been damaged. Request for a new one. Call this toll-free number. A specific message for a specific kind of failure, isn't it?
Yes.
Here, this program doesn't do that. This program is not doing that. Again, that's the main problem. For every kind of failures, we have the same message. So this shouldn't be done. For that reason, the exception handling allows you to have multiple catch. Like this, multiple catch blocks. Okay. Here, you can start using handling one situation at a time. If a null pointer exception happens, okay, now we have 3 catch blocks. Okay, here arithmetic exception, we'll write please enter non-zero numbers in division. Please initialize variable before invoking dot operator. Please access items within the array size -1 limit. Now, if arithmetic exception happens, do we have a generic message or do we have a specific message for this failure only?
Specific.
Okay. If this exception happens, arithmetic exception, you have a matching catch block right here. Okay, a catch block is specifically designed to handle only one kind of failures, arithmetic exception. So does array index out of bound. So does null pointer exception. So that's the reason it allows you to have multiple catch blocks. Okay, it allows you to have multiple catch blocks. So you can take different actions. You can give different suggestions based on what kind of failure it is. Okay, based on what failure you have, you'll take different action. You will give different suggestions to the user so they can avoid this problem in future. So they don't get confused with the same message without telling them anything more specific. Okay, so multiple catch block is allowed, where you can take actions on one failure at a time. Is that clear why we need that and how to use it?
Yes, sir.
Okay. Now, here are some rules. By the way, when you write a program like this, okay, I'll show you the output. Do you see any problem here?
Yes, it only checked the first number 8, line number 8.
That's not the problem. It failed on line number 8, so it went to arithmetic exception. But whenever, what is the main tool to help you debug any problem? What is that you look for in this output to fix the problem?
Where was the error occurred?
Yes. Okay, you need to know specific. You need to know where the error happened. So that red line, which gives you so much insight, right? That red message, the scary red message whenever your program fails, that is the one savior you have. Okay, that's the one thing which will help you out of this mess. But do you see that anywhere? Do you know where the error happened?
No.
You don't. So this is what you guys do. In every catch block, you should always write print stack trace. Okay, e.print stack trace. This will print the stack trace. You know what a stack is, right? So this will print the stack trace. This line will give you the exact error line number, the message, and everything. Okay, the whole who called whom and all that stuff. Without that, you have no information on what happened. Okay, so remember this whenever you have any problem. Okay, so it tells you arithmetic exception happened, divide by 0 happened, it happened on line number 8. Without print stack trace, you will have no information whatsoever. Okay, remember the importance of this. This is very, very important. In any project that you guys work in future, you will end up with hundreds of thousands of lines of code. Okay, any project that you work, no matter how small it is, you'll at least have hundreds of Java programs, and each program will have hundreds of lines of code. Imagine the pain if you have to find out exactly which line your program had an error, your customer had a problem, your website crashed. If you don't want to get into that position, you need this message. Okay, this is the only thing that can literally point out one line out of thousands or even millions. It can literally point out to one line out of millions of lines of code. So understand the importance of this stack trace. Okay, so whenever you write a catch block, do not forget to write this one line, print stack trace. Okay, so E is a reference variable of which data type?
Exception.
Arithmetic exception. Okay, here this E is data type of
Array index out of bound exception.
array index out of bound. They all have the same method, print stack trace. Print stack trace. How is that? These all classes. Arithmetic exception also has arithmetic exception. The variable E also has print stack trace. Okay. Just to avoid confusion, I will write a different name. Okay, this is array index out of bound. This is null pointer exception. Okay, so if you notice, every exception class, arithmetic, array index, null pointer, they all have print stack trace. How is that possible? think inheritance. The clue is inheritance.
Because the parent class is the exception.
Yes, these all have the parent class. The same parent class, isn't it? All these programs have the same parent class. Runtime exception, exception class. So this method is coming down from the parent class. So these classes, since they belong to the same parent, they inherited these methods, print stack trace. Okay, you have to get the gist of, actually I did not give you a clue, I gave you the answer. The answer itself is inheritance. These all classes belong to the same parent and thereby inherited the same method. This is the parent of all. Every single exception that you see down the chain, they inherit from this one class, throwable. So throwable has the print stack trace method, and thereby everything, null pointer exception, your array index out of bound, IO exception, everyone inherited that stack trace method from here. All right. So coming back to the rules. Okay, so now you know that there are three components: try, catch, and finally. Okay, so this is the combination you can have. You can have try and catch without finally, like we did here. We wrote try and catch. Did we write finally? We didn't. You can have try and finally without a catch block, which doesn't make sense. Why would you need something without a catch block? The whole point of exception handling is so you catch exception and take some action. Try finally does not make sense, but yes, if you want, it is allowed. Finally, you can have try, catch, and finally. Okay, you can have try and multiple catches as well. You can have try, catch, multiple catch, and finally. These are the valid combinations that you have. Okay, these are the valid combinations you can use in the program. Try and catch, try and multiple catch, try and finally, try catch finally, try multiple catch finally. Okay, so these are the options you have. Try and one catch, try and multiple catch, try and finally, try catch finally, and try multiple catch finally. Okay, so what I mean is you cannot have just the catch block. Okay, a catch cannot exist without a try. Okay, you should have some code to try in order to catch them. If you want to catch something, you need a try block in combination with catch. Okay, you can have try and finally. Okay, you can have try, catch, and finally. Okay, try, catch, finally. Okay, so remember, try is mandatory. You need the try block in every case. Okay, you need the try block in every case for exception handling. Catch and finally, they are optional, meaning one of them should be present. You cannot have just try block either. Okay, you cannot have just try block. Try should be in combination with either catch or finally or both. Okay, try should be in combination with a catch or finally or both. Remember that. Okay, if you just write try alone, that don't help either. Okay, so that's the rule. Is everyone clear?
Yes.
All right, so now there's one more point you guys need to remember with respect to multiple catch blocks. Okay, these are causing error. So let's see why. All right, so think about exceptions like a bucket. Okay, so you have a parent class, which is the biggest one. Okay, we have a parent class, which is the most eldest and biggest. Okay, and then parent class exception is inherited by a child okay, so this is the exception class, and then you have runtime exception class, which is inheriting from exception. So who is the child class of runtime exception? You know so many runtime exceptions. Name any.
Arithmetic exception.
Arithmetic. All right. So this is the parent of everyone, the biggest one. Okay, everything is inheriting from exception, right? Now exception class is the parent of runtime, and runtime is a parent of arithmetic. If you imagine them as a bucket, okay, so think at how they are positioned. Okay, so let's write all three of them, and I'll show you with the code comparison. We have exception, then we have runtime exception. Okay, these are causing error. These two lines are causing error. Let's see why. The first one is the parent exception, then the child of exception, runtime, then the child of runtime, arithmetic. Okay, this is the order we have placed it. Okay, grandparent, parent, child, grandparent, parent, child. Okay, now this is where everything gets caught. Okay, understand the concept of catch. Okay, these are the catch blocks. Now imagine if it's raining outside and you're doing, rain harvesting thing. So you're collecting water in a bucket. If you position your bucket like this, the smallest bucket in the bottom, a little bit larger bucket on the top, and then the largest bucket on the very top. When you're collecting water, when you're catching rain, will there be any water collected in these two buckets the way you have positioned?
No.
You won't, because this is the biggest bucket that you have, which will collect everything. What happens if when this bucket is full? When the water spills over from the bigger bucket, from here, okay, when the water spills over from the biggest bucket, does the smaller bucket catch any?
No.
It doesn't. It's a common sense, right? When you keep bucket like this, if water spills over, if water fills in this bucket, whatever the spill you have will not be collected by these buckets. Okay, and that's the reason this doesn't work. That's the reason you cannot write like this. Now, the same example, take it in the reverse order. Okay, we'll keep the smallest bucket first, a little bit larger bucket next, and then the largest bucket. All right, so now you're collecting water. The smallest bucket first, little bit larger, little bit larger. Now, when the water is full, if you spill over, will it fall in the next highest bucket?
Yes.
Yes. Whatever spill you have, it will be caught by this. Whatever both the buckets can't catch anymore. If you cannot catch water in both this bucket anymore, where does it go?
Hard one.
In here. So this is the right way to position them, isn't it? It works like a bucket. This is the wrong way. If you ever write a parent class first and a child class later, there is no chance that anything will be caught here. Nothing will be caught here because this is the biggest exception, biggest bucket you have, the parent of all. So if this guy is catching every possible error that comes your way, there is no need for these ones. So that's why Java doesn't allow you to write them in this order. Okay, this is the more suitable order. Okay, so whenever some error is thrown, it will be caught, or to be specific, it will be the first catch block will try to catch it. If it cannot catch it, what does it do? It will spill over to the next one. If that doesn't catch either, it will spill to the next one, and so on. Okay, everyone will try to catch it, but if they cannot, it will spill over to the next one, and the next one, and the next one. But for that, you need to place your exception. You need to position your catch blocks in this particular order. Child class first, then the parent, then the parent. Okay, this is why you're getting this error. Everything gets caught here. This is the biggest exception handler. This class will handle everything. If this exception is parent of everyone and handles everything, the biggest bucket, you will never get caught here. So there is no need of these things. So let's reverse the order. Arithmetic exception being the child of runtime, and runtime being the child of of the exception. Now you have no more errors. Okay, you have a child class, then the parent class of arithmetic, then the parent class of runtime. So does that make sense? How to write the catch order and why?
Yes,
Did
sir.
you guys understand? Okay.
This conference will now be recorded.
String class, as you guys have already seen, is the most used class ever. Okay, next to integers, right? You guys have been writing classes all the time. So you guys create string objects, int objects, the most common objects. Okay, it's the building block of every single Java program. It's the building block. Okay, every program is based on strings and integers. Okay, so string is very, very widely used program, and as you guys know, objects eat up a lot of memory. Okay, so let's take this for example. When you declare a variable student, okay, first of all, out of these 4 objects, what are the 2 main categories of variables? What category of data types do you have?
String and integer.
No, general terms.
Primitive and object reference.
Yes. Okay, you have primitive data type and you have objects. So which are the primitive data types here?
The int variable age.
This is primitive, and the remaining 3 are objects. Okay, these are objects, and the primitive are integer is primitive. So when you declare these variables, this is how it is stored in the memory. Student s, student s2, string, name, and int age. Okay. When you store like this, objects are also called as references. Why do we call objects as a reference and not integer?
They point to the memory.
Yes. Okay. These actually doesn't have any specific value. They are reference to an address in the memory. These three we call as references. Objects are called as references. Primitive data type are not called as reference because this doesn't point to any location in the memory. It literally holds the value that you assign. When you say int age equals 10, it doesn't point to an address in the memory, hashtag 123. No, it will literally hold the values. Okay, it will hold the value of that variable 10. Okay, that's why we don't call primitive as references. Whereas these holds address. Okay, these holds address somewhere in the memory, like this. Okay, so you guys are clear on what a reference is and what a primitive is? Remember this. All right, so that's the reason we call them objects as a reference and not for primitive. Okay, now student s, what is the value?
Null.
Null. It has been declared, not initialized, so default value is null. How about s2?
Some reference value.
Right, you need some reference value because we initialized. When you initialize that, some reference to a memory location within your RAM, within your heap is created, is allotted. Okay, so you specifically give some location and create an object. Okay, like this. So S2 has been initialized, so it is pointing to a reference in the memory. It is referencing an address, and this is the location where you'll find it. Similarly, for name, also you have a reference. Okay, so the value is John. So is everyone clear on what happened in these 4 lines, how they are stored in the memory?
Yes.
All right. Now, here is where you guys might find the meaning of this first line, the definition of string class. String class is an immutable object. Immutable object. Okay, so immutable meaning, do you guys know what a mutation is? What is mutation?
Enhancement.
Enhancement or an upgrade or change. Okay, whatever you're supposed to do, okay, we are evolving every single day, right, as a human beings. The mutation is a process where you evolve new abilities, special powers, something like that. Okay, that's what the term mutation means. Mutation means evolving or changing. To be specific, changing. You're changing day by day. Compared to our ancestors, like hundreds of thousands of years, we are quite different. We are evolving, we are changing. Mutation. Okay, so what would immutable means?
Not changeable.
Not changeable. So let's see why string not changeable. Okay, string is called immutable. Okay, string program, string reference, string objects are immutable. as opposed to every other object. There is a special preference given to string class. Okay, string class is treated very, very differently compared to all the other objects. You can have a student class, a product class, a collection class, system.out class. Every program are exactly operating in the same fashion, except the string program. String program is immutable, unchangeable, whereas every other program, every other objects are changeable. Okay, so let's see how that works. s2.grade, I'm changing to 6. Okay, I'm changing s2.grade to 6. Now, when you say s2.grade 6, where will the change happen?
In the memory block 111.
In the memory block 111, you changed it to 6. So here is the question. Did you change in the same location or did you change it in different?
Same.
Same. That is mutable. Student object is mutable. When you change the value of grade, you didn't go and change somewhere else. You changed it in the same address, 111. In the same address, you changed the value. Did you create a different address when you made a change? No. That is mutable. Okay. When you say age equals 20, where does the value changes?
So 10 will be replaced by 20.
10 will be replaced by 20. Did we create another location or did we change in the same location?
Same location.
That's mutable too. Now this is where things change. Name equals Jane. When you do this, this is where everything changes. If you modify any value for a string, initial value was John. What did we do? We changed from John to Jane. This is where everything changes. It doesn't change in this location. It will create another memory. Okay, it will create another memory with the Jane value, and this new address is copied onto name. This is the only difference with string and every other program in Java. Every other program in Java will behave the same way. Changes in the same location, changes in the same location. Mutable. Every single program behaves like this, except string. When you change the value from John to a new value Jane, it doesn't make changes to the same location. Instead, it will create a brand new object and give that reference to the name variable. This is immutable. So when they say immutable meanings cannot be changed, okay, string is immutable. You cannot change it. Does that mean I cannot change the value from John to Jane?
No.
No. Of course you can change the value from John to Jane. The term immutable doesn't apply to what value you assign, but it applies to what happens in the memory. Let that be clear. String is immutable. Immutable meaning unchangeable. So when you say string cannot be changed, that doesn't mean a name which has a value John cannot be changed to Jane. No, that's not what it means. unchangeable is not referring to the program, but what it is referring to? The memory. It is referring to memory. Once you create an object name with a value John, you will get some memory. But if you change that value, the change will not happen in the same place, but it will happen in another place. Okay, it will create a brand new object and give that reference to the name variable. This is immutable. This memory that you initially gave for name John, this is immutable. This cannot be changed. Okay, in the memory, immutable nature, the unchangeable nature of string is with reference to the memory, not with the program. Your program can change the value, of course, John to Jane, but not in the memory. You will still get the value of Jane. If you sys out name, it will still print Jane because name is pointing to 333, which has the value Jane. No problem. But this is what we are talking about in the memory when we say string is immutable. Is that clear?
Yes.
Okay, so this is a very popular interview question as well. Okay, they try to trick you. Okay, string, the definition of a string class is string class is an immutable object. This is the definition. Okay, this is what a string class is. So they try to trick you. Immutable, what do you mean by immutable? Meaning you cannot change. So does that mean cannot change? Meaning if I declare string name equals John, I cannot change name to Jane? That's what the trick question is. Okay, so they ask you, here you're saying it is unchangeable. And then you say I can change the value from John to Jane. Explain me how that happens. They ask you like that. Okay, so the answer is program wise you can of course change from John to Jane. But in the memory, once you initially assigned a memory for the first value John, that object will not be changed. Okay, that object remains intact. If you change the value, it will just create a brand new string object. Okay, so the immutable nature is not with reference to the program assigning different values. It is with reference to the memory. Okay, understood?
Yes, sir.
All right, so you might feel this is a waste of memory, isn't it? Every time for the same, see, for the student object, if I make changes 10 times, I change the grade from 1, 2, 3, all the way to 10. I make changes to the student object 10 times. How many objects did I create in the memory for student class?
10.
1.
Is it mutable or immutable? I created an object of student, so one object is created in the memory. I made a change the second time. Did I create a new object or did I use the same one?
Use
Same
the
one.
same one.
So if I make changes 10 times, will it be happening on the same one or 10 different times? 10 different objects?
Same one.
Same one.
Same one. Okay. So the same object is changing. Now, with reference to string, if I make changes 10 times, how many objects will be created in the memory for that one variable name?
10.
10 times.
Okay, so don't you feel this is kind of a waste of memory?
Yes.
Yeah. But the whole point of this immutable nature was given to save memory. Okay, so you might feel this is wasting. We have 4 variables and we have 5 objects. We have 5 memory locations because name is immutable. Every time you make changes, we end up creating a brand new. You made changes twice, John, Jane. You ended up creating 2 objects. You make changes 100 times, you'll end up creating 100 string object for that one variable name. That sounds like a waste of memory, but it's not. There is a particular reason on why they chose to do this immutable nature. Okay, let's see that now. Okay, imagine if you're on an Amazon website, right? So a lot of people might be ordering things, right? So they are ordering iPhones and Samsungs. Okay, so as I told you, everything in our Java program is based on string. Okay, so if 1 million customers buy iPhones, okay, in their order, what will be the product name called? It will be called iPhones. So for 1 million customers product name, you have to create 1 million iPhone objects. Okay, you have to create 1 million string objects with the value iPhone. Okay, that's the main problem here. Okay, our program is trying to remember or trying to store all the products that an Apple customer is buying. Okay, so we have 5 customers. Four of them bought iPhone and 1 of them bought iPad. Okay, so let's see why the immutable nature was needed. Okay, so in the Java memory, there is a specific location dedicated for storing only string object. Okay, a specific section of the memory is entirely dedicated for string objects only. We call them as string pool. Okay, if you create a student object, student object will be created here outside the string pool. Okay, you have S student object pointing to location 111, and the 111 is created outside the string pool. Okay, like this. Whatever other objects you have, they are created outside the string pool. Okay, so there is a specific location only dedicated for string objects. Okay, let's see what the string pool is and why we need it. What are the pros and cons? Okay, so customer 1 iPhone. So what Java program does in order to save memory is use the string pool. So what do you understand when you think about pool? Carpooling. What do you mean by carpooling? What's carpooling?
Like a space where you have all the same objects.
Carpooling as a general term, okay, if 4 of your friends are going to the same destination, would you take 4 cars or will you all go travel in the same car in order to save money, time? Have you guys heard the term carpooling?
Yes, car sharing. Like,
Yeah. Okay, carpooling is like if you're traveling somewhere If 4 of you are traveling to the same office every day, in order to save money, you guys will do carpooling, okay, where all of you will take one car every single day. Okay, that's carpooling. Everyone will travel in the same car. Everyone will use the same car. That's where the term string pool is also derived. Okay. So when you see customer 1 has the value iPhone, is there any object already existing that is called iPhone in the memory, that has the value iPhone in the memory? Do you see anything? No. So let's create one. We'll create a iPhone string object in the memory. Okay, in the memory, I'll create iPhone string object, and I will create that in the location 111. Okay, so in the pool, we'll see if there is already someone using an iPhone object or not. If it doesn't, it will create a new one and give that address to the customer 1 variable. Okay, now with the same concept for customer 2, what will happen? Do we have an iPad string anywhere in the memory yet?
No.
We don't. So create one. And give that to customer 2. Customer 3 requires iPhone. Do we have any object with the value iPhone in the string pool?
Yes.
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 What is the address of that object?
111.
111. This is string pool. Sharing memory, saving memory. Just like the car example I gave you. Did customer 3 create a brand new object in the memory or reuse an existing one?
Reuse the existing one.
Yes, thereby saving memory. Customer 4 requires value iPhone. Do we have any?
111. Same.
Yes. Customer 5.
111.
Now, if Apple has 100 million customers who own iPhone, to store that 100 million customers in the memory, how many objects do I have to create?
One object.
Just one
iPhone.
object. Isn't that saving memory?
Yes.
If there are 100 million customers who have iPhone and another 50 million customers who have iPad, if you want to store all that 150 million customers, 50 million customer iPad and 100 million customer having iPhone, to store all that information, all the product order information, how many objects do I need for 150 million customer product detail?
2. 1 for
Just
iPhone, 1
2.
for iPad.
All you need is just 2, because they all are sharing this common pool. Okay, so that's how string operates. The reason they did that was, like I explained, string program is used widely. Okay, everything, anywhere you go, everything will be stored as string. Okay, so you see a lot of information here about the product, product's name, product description. Okay, this is running on some kind of a program, isn't it? Some software program. All this information, this ad, description, the title, this information, if you think programming wise, where do you think, which data type do you think this will be stored in?
String.
String. Nothing but string. If string is so widely used, and you have an opportunity to reuse like this with just that example, to store 1 million customers' product names, iPhone and iPad. I don't need 1 million objects. All I need is just 2. So imagine why they came up with this plan, string pool, just like the carpool example, car sharing example. This is why they chose to give special preference for string objects only, because string is the one program that will be used 90% of the time in your application. So they gave some special preference. In the entire Java memory, there is a special location specifically dedicated for storing string and string objects only. Okay, now that's what string pool is. So everyone understands what a string pool is?
Yes.
Okay. Now getting back to the immutable thing. Okay, why they create a new object? Why did they make string immutable? Let's say, what if customer 4 decides to cancel the iPhone and buy Apple Watch? Okay, if customer 4 decides, I don't want iPhone, I want Apple Watch. Okay, if string was mutable, string is immutable, right? Anytime you do a change, okay, the initial value was iPhone for customer 4 and we changed it to Apple Watch. Okay, if string was mutable, what problem do you see here?
It will change iPhone to Apple Watch.
It will change iPhone to Apple Watch. Okay, if this is what mutable is, if string was mutable and I changed it to Apple Watch, what do you see as a problem?
All the other storing as iPhone they'll lose, I think, their value.
Exactly. Customer 4 is the only one who wanted Apple Watch, but now customer 1, who's pointing to 111, who bought iPhone, their order also changed to Apple Watch. Customer 3 also got changed from iPhone to Apple Watch. 5 also got changed from iPhone to Apple Watch. Imagine if there are 100 million customers who are sharing the same object. Okay, 100 million customers who are sharing or doing string carpooling that same object. One of the 100 million customers changes from iPhone to Apple Watch. What will happen to the remaining 99 million customers? All their order got changed from iPhone to Apple Watch as well, isn't it?
Yes.
That's why they decided this sharing nature might be dangerous when someone makes changes to their string variable. If someone changes the string variable, this sharing nature could be very, very wrong for other programs, other customers, other variables. So they decided if ever someone tries to change an existing value to a different, we make it immutable. We make this object immutable. So customer 4, when they want Apple Watch, is there any Apple Watch in the memory yet?
No.
No. So let's create one. Okay, and only customer 4 will change the reference from 111 to 333. Now the other variables, they are still pointing to their respective iPhone object. Okay, that's why they made it immutable. So immutable nature was given in order to avoid the sharing problem. Okay, since every variable 1, 3, 4, 5, they all share the same object. If one of them make changes to that object, that shared object, everyone will see that change. So in order to avoid that sharing nature, the issue that creates with the sharing nature, they decided to make that string program, the string object, as immutable. So if anyone requires to make a change, you can't make change here. That would impact all the other customers. You can only create a new object and then get it. Okay, so immutable is basically required to avoid the problem created by string pool sharing. Okay, it is a fix. It is a solution to the problem that is created by string pool sharing. Anytime you share something, if 4 of your friends travel in the same car, if your friend who owns the car, he cannot make it to office, what will happen to you 3 guys? You can't go to office either, because you're just relying on that one person to drive you to office, to drive you to a shopping mall. So you have a lot of dependency on that one person. If that one person has any change, they can't make it, they're coming late, you, the remaining guys who are sharing that car, will also get impacted. That's the problem with sharing. The main problem with sharing is that if any one person decides to back out, it will impact everyone. The same problem also appears in the memory as well. Okay, and for that reason, they made it immutable. Okay, just remember 2 points. String pool is used to share or save memory while creating objects, while creating string objects. Okay, so if 4 customer have iPhone as the value, you don't create 4 objects in the memory, you just create 1, and that same reference will be given to all the 4 variables. So you're sharing that same memory, you're sharing that memory, thereby saving memory. Okay, but this creates a problem. String pool creates a problem. What is that problem? What could be the problem with sharing?
Everybody will get affected.
Yes, if someone changes the value, everyone gets affected. That's a sharing problem. Okay, if anyone makes changes, it will reflect to everyone. So why did they do immutable? To fix that problem. Okay, if any one person does a change, they will do that in a different place rather than the same object. That way, all the other folks who are still pointing to that address get the value that they initialized. Okay, so string, all you need to remember is pool, what a string pool is, why we need it, and you need to remember why we made it immutable. Okay, we made it immutable, so whatever problem that occurs with sharing, we can avoid that. Okay, so if you try to change any value, we won't change it in the same location. If we change it in the same location, other people will impact. So what we do, we make this object immutable. You cannot change this. If you reassign a different value, we'll give you a brand new object. You can play with your own object now. Okay, so that's what string class is all about, how it works in the memory and all. Okay, now this string program can be initialized in two ways. Okay, so just like student, how do you initialize student object? How do you initialize student or product object?
Student S equals to new student.
Right. Similarly, you can also initialize like this, just like any other program. But this is not encouraged. When you do like this, using a new operator, you're not going to reuse the object in the memory. Okay, you will not be reusing the object in the memory. Instead, customer 6 will have an iPhone object created outside the shared pool. Okay, customer 6 will not point to address 111. What it does is it will point to a address outside the sharing pool. Okay, it will be pointing to an address with the iPhone value outside the pool. So if you do like this, aren't you losing that whole benefit of string pool? If every customer of Apple was created like this for 150 million customers, how many objects would you have? 2 or 150?
150.
150 million. So using new is not encouraged. You are allowed to, you're allowed to create like this, but this is how we create string objects. Okay, this is what we encourage. You can create both ways. String is after all a reference, after all an object. Every object is initialized with the new operator. Student S equals new student. Bank account equals new bank account. Product equals new product. Every object is initialized like this. But string specifically, we do like this. That will allow you to save memory by using the pool. But if you use new, this iPhone string will be created outside the pool. Okay, now pay attention to this part. Listen carefully what I say. What is the value of customer 1? I'm asking the value of customer 1. What is the true value of object?
111 reference address.
Very good. Reference. The true value of object is reference. Okay. If you print student S2, it doesn't print 6. It prints something like an address. If you print int, it will print the value, isn't it? Always remember, the value of objects are references. They are called references. The value of objects are references. It's not 6, it's not John, it's not Jane. The value of name is not John or Jane, it's a reference. Okay, remember always. Sits out both of them, the customer 1 variable that you initialized Okay, bank account has balance. So when I print customer 1, will it print 100 balance or the reference?
Reference.
Age has the value 2. Will it print some reference or value 2?
To value 2.
Yes. Okay, look at the output. Int age variable prints the value directly 2. When you print the customer 1 reference variable, it is giving you a reference. Does it say balance 100 or something? No, it gives you the reference. Always remember that. So here, my question is, what is the value of customer 1?
111.
111. And what is the value of customer 3?
Also 111.
111.
So this condition will give you true?
Yes.
Yes.
Yes. This will give you true. Similarly, okay, look at this. Customer 6 has the value iPhone. Customer 3 has the value iPhone. Customer 1 has the value iPhone. Even though all the variables 1, 3, and 6, all the customers have the same value iPhone, you will get different results. That's what I'm trying to show you. Even though they all are iPhone. Okay. Customer 1 was initialized with iPhone. Customer 3 was initialized with iPhone. Customer 6 is also initialized with
iPhone.
iPhone. They all are initialized with iPhone. But when you do this comparison, what you look for is the real value of customer 1, customer 3, customer 6, which happens to be addresses. 111 pointing to iPhone, 111 pointing to iPhone, 777 pointing to iPhone. They all, customer 1, customer 3, customer 6, they all have been initialized with iPhone. So technically what we assume, this should give true and this should also give true. Okay, we assume this is the case. 1 and 3, they are both iPhones. 1 and 6, they are both iPhones. This is what we feel. But since objects do not have the values of iPhone or iPad or Apple Watch, objects have references. Object's true value is its reference, just like what you saw here. If you print the object customer 1, you get address. If you print the primitive data type age, you get the value. Okay, these are always address. They don't give you the real content behind in that address. Okay, so what will happen in case of customer 1 equals customer 6?
False.
This will be false. And why?
Different memory allocations.
Yes, customer 1's value, true value, is 111. Customer 6 true value is 777. They are not the same. Even though the value, the string object in that location is same. Okay, the string object in that location is same. The address are different. So this will give you true. However, this will give you false. Okay, so when you are comparing two strings, do not use the equal sign. It's not reliable. Okay, so we have something better. Okay, print out all of them. You print all of them, and they all will say I am iPhone. Okay, they will all give you the same value iPhone. Okay, but remember how memory operates. They are not values, but they are references. Okay, so what we do here is we'll print the comparisons. S1 equals to S2 and S1 is equal to S3. True. These two are created in the pool or outside the pool?
Inside the pool.
Inside the pool. And when you say new string, it is created inside the pool or outside the pool?
Outside.
Outside. So when you create it inside, they both share the same object. When you create outside the pool, they have their own copy. Okay, inside the pool, they share. So that's why S1 and S2 will be true, because they both are pointing to the same object in the memory. However, S1 and S3 is false. Right? So you shouldn't compare, when you're comparing two string objects, don't compare them like what you do with primitive data type. Okay, amount equals balance and all that. Don't do like how you use the operators in the primitive data type. Okay, string will give you different answers based on how it was created, inside the pool, outside the pool. Even though they all are iPhones, all the string has the same value iPhone, you'll get different results based on how it was created. Okay, remember that.
This conference will now be recorded.
All right, so quick recap. Now, S1 equals iPhone. Where will the object be created?
In pool.
S2 equals new string iPhone.
Outside pool.
S3 equals iPhone.
It's already in pool.
Very good. It's already in pool. So you don't create, you just point to this existing object in the pool. Very good. S4 is S1 plus X. What is the value of S1?
iPhone.
iPhone. iPhone plus X gives you iPhone X. So do we have anything called iPhone? First of all, are we using new here when we initialize S4?
No.
No. So will it, whatever comes out of this expression, will it be inside or outside?
Inside.
Inside.
Inside. Very good. Okay. So S1 plus X gives you iPhone X. do we have anything called iPhone X in the pool?
No.
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 So create iPhone X. Finally, string 5, new string iPhone, inside or outside?
It's outside.
Will it reuse or create a new one?
Create new one. It's new.
Yes. Outside the pool, there is no sharing. Only inside the pool, there is sharing. So with this program, how many objects totally were created in the Java memory?
2 objects in pool, outside pool.
2 in pool, 2 in out, total 4. Okay, so remember this. This is also a popular Java certification questions. How many objects are created in pool, out pool, and something like that. And also some interview questions also. Okay. So they'll give you a program like this. They'll ask you how many objects were created. This is what we call literal initialization. And this is new initialization. The term literal is derived from the primitive data type. In the primitive data type, you do not have anything new, right? Int age equals 20. This is literally a value 20. Is there any reference, new or anything? No. Okay. So this is what we call literal value. And this is a new initialized value. Okay. Literal values are usually inside pool. The new initialization is outside the pool. Okay. Remember that difference. Now, we already know what is the benefit of pool. For 150 million Apple customers, all we need is 3 objects. For a billion Apple customers, they have billions of products, billions. All we need is 3 objects to store which customer has what product. Okay, we know, we clearly see what is the benefit of pool, right?
Yes.
Now, let's see what is the drawback of having a pool. Okay, what is the drawback of having a pool? Let's say you're creating an email and there is an email body string. So I say hi, and then I say something like this: email body equals email body plus. Okay, so then it will say hi John. Okay, so you're sending an email to your customer saying there is an offer, and this is what you did. You have the value hi, then you write the value, append the value John. Okay, then you tell what is the offer and which website and all that. Okay, now here you're doing a lot of editing, aren't you?
Yes.
Editing requires change, and every time you change a string object, what happens in the memory?
New location.
New object is created. So the first line was there was one value, hi. The second line, when you say hi plus John, what is the new value?
John.
Hi, John.
Hi, John.
Hi John. Before that, even this is a string literal, isn't it? The double quote John. This is another literal. This is another literal. Every double quote is another string literal. Remember that. Okay. So hi plus John gives you hi John. Then
Hi, John. 10% off on all sales.
so you see where I'm going with this, right?
Yes.
So in the end, all you needed was this thing. Okay, in the end, all you needed was this one thing. Hi John, 10% off on all sales on our website. Offer ends on July 30 from your sales team, retail website. This is what you needed in the end. How many objects do you end up creating in the pool? Every time you make changes, you have to create a new one. Make change, create a new one. Make change, create a new one. So how many did we create to store that one offer? 11 objects. So the drawback in string pool is if you're doing heavy editing in a string variable, if you're editing or changing a string variable very often, this might turn out to be a bad idea. Okay, you might actually here you saved by sharing. Okay, the pool the reason of pool is sharing. So here you save. You need 3 objects for storing a billion Apple customers. You're saving. Here, to send out one email for one customer, you ended up creating 11 objects for one customer. So when do you not use string?
When we have to edit often.
Yes. If you edit or change a string variable quite often, string is not your best friend. String will end up wasting your memory. See, look out. These kind of email comes to you all the time, right? Sales, offer, and all that. Is every customer's name John?
No.
No. This will keep changing. It will become John, Jane, Mike. So this, every time you want to send out an email, this will not be the same. Okay, there won't be an existing object called Hi Jane. You have to create another such. If you want to send another email, you'll end up creating this that many times. If you have a million customer, for every million customer, the names will be different. John Doe, Jane Doe. So you'll end up creating this in the memory over and over, thereby wasting memory. So if you're doing editing, if you're changing values, string is not your best choice. Okay. For that reason, what they have is something called string buffer. and string builder. These are another two classes that operates just like string with one key difference. String is immutable. Immutable meaning if you make a change, you'll end up creating in a new place. You make a change in a new place. Immutable. That is what is wasting memory here, right? So can you guess what they did in string buffer and string builder?
Mutable.
Yes. They made string buffer and builder as a mutable. So any changes you do, you won't end up creating 11 objects. You will have just one. Okay, so this is how you do that. sb.append, append is like addition, hi, okay, then sb.append when you do this, in the end, how many objects will be created in the memory for string buffer and builder?
One.
Just one. And that value of string buffer will be this final editing. This SB variable will have this value, just like what string has, string buffer and builder also has it. You'll have this value, the same string value in this program, string buffer and builder. But you will save a lot of memory. Okay, so you see there are pros and cons for everything. Okay, if your value doesn't change, it's not like Apple is going to call iPhone something else, isn't it? For more than a decade, they still call iPhone as iPhone, don't they? So do you assume they will change the name iPhone anytime soon? No, right? So it makes sense using string pool, the string object, while storing the Apple customer product names, because they don't change iPhone name like every single day. They don't change it every day or every hour or every year. It has been iPhone from day one, and it's an iconic name, and they might not be planning to change it anytime soon. So you save memory. This value, iPhone, iPad, they won't change. They'll always be called iPhone and iPad. So it makes sense here. You'll save a lot of memory. Instead of a billion object, you just need 3. So it makes sense in situation like this. But when you're editing, okay, when you're sending email, you have to write a code like that. Because every time you send out an email to 1 million customer, 1 million customer will have different names and they will have different offers. For a customer in New York, there might be a 10% off. For a customer in California, there might be 20% off. The offer ends on June 30th for customer in Washington. So this email changes from person to person. So what we end up doing is editing. So when we edit this, we unknowingly end up wasting a lot of memory. So here, the variable email body changes, and here, the product names won't change. Here, it's a very, very good thing. It will save you a ton of memory. And here, it will waste a lot of memory. You will end up using 10 times more memory than what would be needed, 10 times more than what would make sense. Even more, if you do like 100 editing, you'll end up using 100 times more memory. So this is the con, that is a pro. The solution for this problem, wastage of memory, when you do editing, is string buffer and string builder. Okay, string buffer and builder is a solution for your memory wastage when you do editing. Is that clear?
Yes.
Now string buffer is synchronized and string builder is not synchronized. I won't go in detail for this because you need to know what a thread class is to understand the term synchronized. Okay, so we have two categories, synchronized and not synchronized. Okay, but I'll get back to you on this when we are done with the thread chapter. Okay. All right, so finally, let's quickly have a look at all the methods that you have in string program. All right, so until now, all you guys did was declare string variable with a value, but string has a lot more benefit than you realize. Okay, let's look at them. Now string is like an array of characters. So do you guys recall what is the primitive data type for characters? What is it called? What is the primitive data type for storing characters?
Char. CHR.
Char.
Okay, so you store one character at a time. Okay, this is like a character primitive data type. Okay, as opposed to string, which is a group of characters, isn't it? This is a group of characters. String is a group of characters. The char data type is more like one character. Okay, this is primitive and this is the string object. Okay, so string is a group of characters. Okay, string is a group of characters. Think like an array. Okay, think like an array. What is group? Arrays. So if you imagine this as an array of character, what is the index of this?
0.
0. The first character in the string is 0 and the second character is
1.
1 and so on. Okay, so think about string as a array or a group of characters. Okay, so you have a method name.char at 0, meaning get me the character at index 0. So name is declared here. What will it print?
J.
J. Character at 0. Give me the index. Give me the character at index 0. Okay. Concat. Concat is just like the plus operator. Okay, when you join two strings, you use the plus operator, right? So you concat is an alternative for that. So the current value of name is John Doe. You concat comma last name. So John Doe comma last name. Okay, that's what the concat method does. Contains. Contains will return you a Boolean value if the name variable contains this string. If the name variable has dash, this will return you true. So does it have a dash value? A substring called dash?
No.
No. So it returned you false. Okay. Now think about what could be the application for this method. What would you use this for? in which case I give you a string value and you want to check something in that string value. Where
Like
would you need this?
saving the username or saving the password if it has some special factor in it.
Yes. Okay, what if you want to check if the customer entered a valid email ID or not? What would you want to check in their input?
At the rate.
Yes. You want to check if it has at the rate. If they have at the rate, then we know that they entered a valid email ID. So this is what string provides you. It is not all about just declaring variables. There are so many methods in the string class which you can use to your advantage. You can extract what is the first character, what is the last character. Okay, so any usage you see here,
Well, we can say like the first character should be capital.
yes.
Can you check it?
Yeah. If you are looking for an area code, you are a cell phone provider in a particular area and all your phone numbers start with 8. Okay, and you want to make sure that whoever is calling, they only dial the numbers in this area code that starts with 8, because I'm a cell phone provider and all my numbers are starting with 8. You can use that carat. Good. Now contains, look for this string anywhere in the middle. Okay, so if I write OH, will it give me true or false?
True.
True. There is a OH, so it gives me true. Okay, so the contains looks at anywhere. The number, the letter OH should appear anywhere in the name variable. So there it is. So it will give me true. Okay. Similarly, you can use ends with. I already gave an example. What would you use this for?
Email.
Email. Okay, so if your website takes email ID for registration, and if you just do @, if I do like this, won't you assume this is a valid email ID? Your program is checking for contains @. So won't your program assume this is valid?
Yes.
But is it truly valid?
No.
No, it doesn't end with .com. So for that kind of requirement, you can use ends with. So you can check both contains @ and it ends with .com. Only then it is a valid email ID. You can check that. Now this is what I was talking about, equals. Okay. Why shouldn't you use equal sign to compare two string objects?
Compares the reference.
It compares the reference. Okay, if you use like this, it compares the reference. If S1 is created literal and S3 is created with new, will they match?
No.
They don't. One is created inside pool, another is created outside. They won't match. So equal is not the right way to compare two strings, this equal sign. It is okay if you're using it for primitive variables. Okay, you can use it for primitive because primitive do not have references, they have values. So for primitive data type, this makes sense. For string objects, this will not make sense. It will work sometime and sometimes it won't. Okay, for this, we have a method called equals. S1 equals S3. So when you compare two strings like this, you're not comparing references, but you're comparing its value, its string object value. So this time it won't compare references, it will compare what is the value in that reference. That's the difference. Okay, so here this will give you error, but when you say customer 1 dot equals customer 6, when you say this, it won't compare references, it will go to customer 1's address 111. What do I have? iPhone. Customer 6 777. What do I have? iPhone. Now don't compare references, compare the value in those references. iPhone and iPhone, are they equal?
Yes.
Yes. So this will give you true, whereas this will give you false. Okay, so do not use double equals for string, use this instead, dot equals method. Okay, a string object has equals method that takes another string object for comparison. Okay, customer 1 dot equals, it takes another string object for comparison. In this case, it is customer 6 object. Now this is slightly an upgrade from equals. Okay, will this work?
No.
Lowercase, uppercase. Even though the value sounds same, John, but the case is different. So this will give you false. Okay, this will give you false. Equal ignore case will give you true. Ignore case meaning whatever uppercase, lowercase differences you have, ignore that. Okay, that's the upgrade to the equals method. Okay, so in the user ID and password comparison, okay, customer enters user ID password on your website and you check that with your records. For which comparison would you use equals, and for which comparison would you use equal ignore case? You're comparing customer entered user ID on your website with whatever you have in your registration records. You do the same for password. Customer entered password and what you have in your records password. So the question is, where would you use equals and which one you'd use equal ignore case?
Equals for password and ignore case for the username.
Yes. Why wouldn't you use equal ignore case for password?
It needs to be the exact same.
Yes. So when you go to a website on purpose for more security, they ask you to enter uppercase character, lowercase character, a special character, a number, a mixture of all. If you do equal ignore case, you beat that whole purpose of having a mixture, the security. So equal ignore case would make sense for user ID. It will not make sense for password, because on password you specifically have to compare a lowercase with a lowercase, an uppercase with an uppercase. You can't ignore the case. You get the idea, right? Yes?
Yes.
All right, so index of. This is the opposite of char add. In char add, you give the index and you get the character. Okay? Here, you give the character and you get the index back. Okay, you give the character and get the index back. So this is the string name John Doe. So when I say name dot index of O, what do I get? What is the index of O character?
1.
1. Okay, so that's the difference between these two. Last index of gives you the last appearance of that character. Okay, so when you're looking for O, there are two O's here, one in the beginning, one in the end. So when you say index of O, it gives you the one from the beginning. Index is 1, 0, 1. Last index of gives you
6.
what's the last? This one. Okay, 0, 1, 2, 3. There is a white space. 4, 5, 6. It will give you 6. It will give you the last index of. Okay, now where could you use this?
Last 4 digit of social security, something like that.
Last
4 digit of social security, like in the bank, they ask something like that. We can use that.
Okay, yeah. Okay, let me ask you this thing. If this is your string, okay, and this is what I do. If mail dot contains @ and mail dot last index, not last index, ends with .com, sys out valid email ID, else sys out invalid email. So what will it print?
True.
True. Mail dot contains @. Yes, it has @. It ends with .com. Yes, it ends with .com. It will say valid email. Okay. What if I do this?
Still prints true.
It says valid email, but is it truly valid though?
No.
No. So how can you use index of to fix whatever this problem is?
If you say index of @ is not equals to 0 or like greater than 0.
Yes. Index of @ is greater than 0. Okay, if it is greater than 0. So if this is here, it will be greater than 0 or equal to 0.
Equals to 0.
Equals 0.
Will it print invalid email or valid email now?
Invalid email.
Valid. Okay. What if now?
Valid.
There you go. So index of can be used rather than contains. So this is the kind of utilization you can do. You know, there are so many methods here in string, and we use it every single day. Ends with, contains, index of, equals. These are very popular. There are quite a lot of methods, but these are the most common ones we use that I've listed here. These are the most common ones we use regularly. Okay. So it makes sense to use index of rather than contains. One thing you need to remember, if there is no @ what will this index of return? If the string that you're looking for is not there, it will return you -1. Okay, it will return you -1 if whatever you're looking for doesn't exist. Okay, so all the positive numbers 0 and above, meaning it exists. Okay, any number from 0 to n, meaning this string exists. If it doesn't exist, you get -1. Okay, remember that. So even in this case, this condition still holds good. Index of @ it is -1. Is -1 greater than 0?
No.
No. You will still print invalid email. So it's a good thing. Okay, remember, index of will give you -1 if whatever you're looking for that doesn't exist. If it doesn't exist, then any 0 to n index doesn't apply. So we give -1. Okay. All right, so replace all and replace first. Okay, so replace all the occurrence of search and replace. Okay, this is basically a search and replace function. Look for this and replace with this. All the occurrence. In this case, it is basically replacing the first occurrence only. So here, if I say look for JO and replace with look for O and replace with A, when you do this, what will it print?
It will replace O and put A instead of O.
So JAHNDAE. Okay, all the O will get replaced with A's. In this case,
Only O in
Only the first O will be
the first O will get replaced. Okay. Split. Okay. Split basically divides your one string value into an array. Okay. So here is a classic example, right? If you have a phone number, okay, like this, 123-12222-1234. Now what if you want to extract the area code from this phone number? Okay, what we do is we do split by dash. When you say split by dash, when you split by dash, how many items will be here?
three.
3. There is 1, there is 2, and there is 3. So there are 3 different strings now. So split method does return you an array. It returns you an array. Okay, the split method returns you an array. That is a group of this division. So if I print phone div.length, what do I get? This is an array.
3.
You give it 3. 1, 2, 3. If you need the area code, what do you do?
Index 0.
Index of 0. Okay, so when you say split, basically whatever that special character, whatever character you're looking for to split, it will divide this into an array. Okay, by 1 2 3 2 2 2 and 1 2 3 4. Okay, it will divide by whatever split criteria you gave. Okay, and you'll get 3 numbers like this, 3 string like this. Okay, now this will be stored in your array phone div. So if you need the first number, as usual for arrays we say index of 0. So this is what gives you the area code from your string. Okay, from your string that you have this, you get the area code. Okay, so you can use split for extracting area code from a phone number. What else do you see the benefit of split?
Here I have a question. Like,
Yes.
what if you want to add the special character in the number? Like, whenever we enter a number and we enter like 7 or 8 digits, it automatically divides into area code and then give the splitter in between. So what can be the code for that?
So what you're saying is customer entered a wrong phone number with the 8 digit?
No, customer enter a phone number, but when we save it, it automatically gives the hyphen or the line in between, like it divides the number. So how can we do that? Is it by a string function or?
Yeah, so here is what you can do, right? You can use the index of and substring for that reason. Okay, again, that is not relevant. Whatever question you're asking, that answer is in another method called substring. Okay, that doesn't apply for split.
Okay.
Okay, I will show you how to do that. I'll show you how to do that, but that doesn't apply for split method, is all I'm saying. Okay.
All right, thank you.
All right, so what is the usage for the split method? Give me a live example where you might need it.
To get words from the sentence, like single words from the sentence.
Yes. So in that case, what do you split by?
Space.
Very good. You can use space split, and that will give every single word in your sentence. Yes. What else?
First and last name.
Very good. Okay, you ask customer to enter their full name. When they enter it, you split and you get that. Yes. What else?
Month or day from the date.
Yes, of course. Okay, if you have a date of birth from your customer and you want to know what month and date and year, you can split by this. And the first item in the array will give you the month, second item will give you date, third item give you year. Okay, so you see the benefit of all these various methods. You can play with these methods every day. You'll be using this every day. There's a lot of benefit, not just declaring string variable, but string in fact has so many useful methods. Okay. All right, so now we come to substrings. the first substring, first of all, there are two methods, substring, substring. What does this remind you? Which Java feature does this remind you?
Polymorphism?
Yes. Same method name, same operation, but with different input. One takes a single integer, another takes two integer. Polymorphism. You can extract a substring in two different ways. Let's see how. The name has John Doe. The first method takes one integer 5. This is the index number. So 0, 1, 2, 3, 4, and 5. So what is the character at index 5?
D.
D. So if you pass just one integer starting from that index till the end, DOE, starting from that index till the end is what you can extract. Substring, it is a subcategory. Okay, you can extract a subcategory from the main variable name's value. So when you say substring 5, what does it give you? Doe. Okay, now the second polymorphism overloaded method is start index and end index. So index 3, 0, 1, 2, 3. What do we have at index 3?
N.
We have n. Okay, start from index 3 till index 6. I'm not saying including index 6, I'm saying till index 6. Okay, so starting from 3, 4, and 5 till index 6. Okay, so what do you get when you do a substring like this? Start position and end position. N space D. That's the second substring. Okay, do you guys follow? Substring, you can extract a small portion of the main string by two ways. One, you give the start position and it will extract the value from start position till the end, the first method. The second method allows you to extract exact index, starting position and ending position. Okay, that is substring. Okay, so Rohil,
Yes, sir.
let's get back to your question. If this is your phone number, how do you add the dashes?
Name dot substring 3.
Very good. Okay, so first you do a substring. What is the start position? 0
0
till
3.
Okay, 0 till 3. So starting from 0, 1, 2 till 3, not including 3. Okay, so you get 1, 2, 3. Okay, here I will add your dash. Now, what's the next set of characters?
4 to 6.
0,
3 to
1,
6.
2, 3, 4, 5 till 6. Remember, index starts with 0, so you don't say 3, you don't say 4, you say 3. Index is size -1. Okay, And finally, starting from 0, 1, 2, 3, 4, 5, and 6. Starting from this position till the end, isn't it?
Yes.
So now you don't need start and stop because we need everything till the end. So instead of saying 7, say 6. Okay. 0 because it starts with 0. 0, 1, 2, 3, 4, 5, and this is 6. So when you say substring 6, what you get is starting from this character all the way till the end. So this is how you can insert those dashes. Okay, make sense?
Yes, and we can save it in the same sysout line, like string new number equal to this phone.substring03.
Yeah, because you can only do one substring at a time, don't you?
Yeah.
So you have to extract the first 3 characters, then the next 3 characters, then the next 4 characters. You extract that and then introduce, because it only takes one start and end position. Here there are 3 start and end position for the state, for the area code, and all that. So you need 3 parts. Okay. All right. So here the next ones are 2 lowercase and 2 uppercase. Okay. So basically, whatever character you have, it will convert everything to lowercase or everything to uppercase. Okay. So here, if the name is like this, just say name dot to lowercase, and it will basically convert every character into lowercase. Make it uppercase, and every character will be uppercase. Okay. We usually use this when customer enters the user ID. When you are registering or when you log in, your caps might be locked. Okay. Your capital, the keyboard might be on, so you might unknowingly enter capitalized user ID. So we can actually make everything to lowercase or everything to uppercase, just to have that consistency. Okay. So when you do register or login, user ID alone can be converted to all lowercase or all uppercase, so that customer doesn't make a mistake. Okay. And the last method is trim. Trim is used to remove white spaces. Okay. Not in the middle, but before and after. Okay. That's what the trim method is used for. So here, if this is your string, when you say trim, it will trim at the edges here and here. Okay, it will only trim white spaces in the edges. Okay, that's what trim method does. So we can use it for times like people entering their user ID password and unknowingly they hit a space bar. So we know that user ID passwords do not allow white space. So if it happens by mistake, maybe you can remove it for the benefit of user. Okay, you can remove it from the beginning and the end. Okay, so that's what you can use the trim method for. Okay, so these are the basic methods that you have in string class, and there are a lot many other methods as well, but this is what I handpicked because we use it a lot. Okay, the methods are listed here, we use it every day. But as you see, there are so many methods here. Get bytes, get this thing, is empty, split, starts with, ends with. Okay, there are so many methods here. Okay, but these are the ones that you might end up using every single day. Okay, then those are the ones I listed here. Okay.